Hello, scholars! So question number 1 on the Unit 6 test asks you to find the distance between 2 points. We have point P at the coordinates 8, 2, and the coordinate Q at the coordinates 3, 8. And then you're asked to round the distance between these 2 points to the nearest tenth. So that's one place after the decimal point. So to solve this problem, it's helpful to know the distance formula, which is given right here. And whenever you're doing a distance formula problem, it's helpful to first label the x and y coordinates on our points. So we know that every point is given by an x and a y. That's just the rule for when we plot points on a coordinate plane. So this first point P would be somewhere like 8 in the positive x direction, 2 in the positive y direction. That would be P. Q would be 1, 2, 3 in the x direction, 1, 2, 3, 4, 5, 6, 7, 8 up here in the y direction. Remember, we have our x-axis and our y-axis. Okay, so we're being asked to find what is the distance between these 2 points. Okay, so we labeled x and y, and then you see here how in the distance formula we have d equals the square root of the distance between the x coordinates squared plus the distance between the y coordinates squared. This formula we explored in class really comes from the Pythagorean theorem. So I'm really quickly going to explain where this formula comes from and then how to use it in this problem. So the distance between the x's, what that means is if you had these 2 points, so our P and our Q, oops, I forgot to label that Q. So here's P and here's Q. The distance between their x coordinates is this distance right here, okay? So we have P and we have Q, and they each are given by an x and a y coordinate. This distance right here is the distance between their x coordinates. So if we were to plug that into the formula, we would have the distance between P's x coordinate and Q's x coordinate. And it's helpful, again, let's call this point 1. Let's call this point 2, because we see how we need the second x coordinate minus the first x coordinate. It doesn't really matter which point you call point 1 and point 2, but once you do that, we'll call this x sub 1, y sub 1, x sub 2, y sub 2. So we just, instead of calling them points P and Q, we're calling them points 1 and 2. That kind of rhymes. Okay, so the distance between the x coordinates, we have x2 is 3, and x1 we've now called as 8. Remember, we're subtracting that distance and we're squaring it. Plus the distance between the y coordinates. So my y sub 2 is 8, and my y sub 1 is 2. And we're subtracting those values and squaring that value. And the distance, or the difference between my y values is really this distance right here. So whatever this value is should be the number of boxes on my graph between those 2 points. So next up, we're just going to simplify. D, or the distance, equals 3 minus 8 is -5. We're squaring -5 plus 8 minus 2 is 6 squared. Distance equals, now -5 squared is the same as -5 times -5. 5 times 5 is 25, and a negative times a negative is a positive 25. So anytime we're squaring a negative, it's going to end up positive. Plus 6 squared is 36. Now you'll notice here, there are 6 boxes between the x coordinates of P and Q. That's where the 6 came from. And those are the y coordinates. There are 6 boxes between the y coordinates for these 2 points. If I were to graph this better, 1, 2, 3, 4, 5, 6, that's the distance between the y values. Okay, I could draw a line here, those y values. And there's a distance of 5 between my x values. If I were to count the number of boxes, I would have 5. It's on the x-axis, so there's 1, 2, 3, 4, 5 boxes between those x coordinates of these 2 points. We happen to get a negative number here, but if we had reversed points 1 and 2 and done 8 minus 3 squared, we would have gotten 5 here. So ignore the negative, but we know that there's 5 points between here. We could have also reversed this 8 minus 2 and done 2 minus 8, which would have gotten us -6. Squared would get us the same 36. This is getting us that same 8 minus 3 is 5, squared of 25. So it doesn't matter which x or y comes first. So we have to finish this problem. Distance equals the square root of 25 plus 36, which equals the square root of 61. And this problem is asking us to round to the nearest tenth. So they want a decimal point rounded to one place after the decimal. So let's check this out. I'm going to take the square root of 61, and that equals 7.81024966. Round to the nearest tenth would be 7 point, where'd that go? 7 point, okay, well, I'm going to write out some of the decimals. The tenth is this place right here, one place after the decimal. I'm looking at the number after, so the number in the hundredths place. It is not bigger than 5. This value is not greater than 5. It's 1. So I'm not going to round up. I'm not going to do that. So my answer is left as the distance equals 7.8. There are 7.8 units between points P and Q. Okay, so I thought about what this meant. I plotted the 2 points on my graph. You can't ever count the units in a diagonal line. That's why we had to use this formula. I labeled the points 1 and 2. I gave each point an x and a y coordinate, and then the point 1 coordinates I gave subnumbers of 1, subnumbers of 2. Then I just plugged them into the distance formula. I squared my values, I simplified my radical, and I got this decimal rounded to the tenth. Oops. Done.